everyone, welcome to our channel Euclid Mathematics. In my today's video, I will explain to you all group and subgroup for non-abelian groups. So if our group is having prime order or the group is having order which can be written into the multiple of two elements, which both are the prime, okay, like a P and Q both are prime. Okay, so then how to find the subgroup of our group? In my previous video, I explained to you all, if we select the property like our group is of order is a P and Q and both are prime, then how one can find their subgroups? So if you wanted to see how to find subgroup of two prime order, you can check it into my playlist. All these videos are more important for different competitive exams like say NET, GATE exams, and for B.Sc, M.Sc level students too, because this subject is quite important for all the branches. Okay, so let's get started to our today's lecture for groups and subgroup for prime element. Okay, so initially I considered here a group of order is okay, which is not prime. Okay, group of order 21, and then we have to find out whether the subgroup of order which exists there or not. Okay, now let's go for the solution of example. Okay, if we consider, let's read the example first. If order of G is a 21, okay, group of order is a 21. So why I consider 21? Because the 21 can be written as a multiple of a two prime number, okay, which is a 7 and 3. Okay, 7 3s are 21 and both of the elements are prime. Okay, so here order of G is a 21, then possible order of element, we want the possible order of element by using Lagrange's theorem. Okay, and our example say that G is a non-abelian, order of G 21 and G is non-abelian. Then how many subgroup of order 3? We want the subgroup of order 3. That means there exists an element of order 3 where we have to find out the subgroup of order. So by using Lagrange's theorem, we know that order of group can be divided by order of subgroup. So order of group is a 21. It can be divided by order of subgroup. So what is the possible order where we can divide to 21 by using Lagrange's theorem? Okay, Lagrange's theorem, it says that our group order divided by its subgroup order. Then possible subgroup of our group, 21 divided by 1, all divisor for 21, 3 also divides 21, 7 also divides 21, and 21 also divides 21. Okay, these are 4 possibility here for each, which is a subgroup of our group. But we are not sure about here that all 4 elements are the subgroup. We have to check whether they are subgroup or not. We are not sure all subgroups there. Okay, so given some properties in our example that G is non-abelian. If G is a non-abelian, then it is a non-cyclic. If our group is a non-cyclic, that means there does not exist any element whose order which equal to the group order. Okay, cyclic, what is the definition for cyclic element? There exists a element whose order which is equal to the group of order. This property has to be a fold and the group need to be abelian. This property if fold, then we say that it is cyclic. Okay, then if group is not abelian, that means it is non-cyclic. Non-abelian group always non-cyclic. So if G non-cyclic, then there does not exist any element whose order 1. Okay, that means if G has an element of order 21, then G is cyclic. Okay, but as I know G is cyclic, then G abelian, but we have given G non-abelian, then G is non-cyclic. Okay, that means G has no element of order 21. So if G has no element of order 21, then G has no subgroup of order 21. Okay? If the group does not contain that specific element, then group does not contain that element of order subgroup of element. Okay, so let's go for the further step. We have to check whether 1, 3 and 7 their subgroup, what order of subgroup exists there. Okay, so hence possible order of elements in a G are 1, 3, 7. Okay, so if we come to know the possible order for element, it is easier to proceed further for their subgroup of order. Okay, so you can see here first task, it is here number of element of order 1 in a G. So number of element of order 1 in G, it is 1. We know that only the identity element is there in our group. Okay, if we call that is a group, our order of G is a 21 and it is a group, that means there exists an identity element. Okay, always identity element present there. Okay, so if identity element is there, then number of element of order 1, identity element is only there whose order 1. Okay, now let's go for further. I got the first element of order 1 whose element 1 whose order is 1. Okay, now next element, it is here 3 and 7. So let's find out the element of order 7 in G, and we know that element of order 7 in G is a 5 of 7 and 5 of 7 is a 6 by using Euler 5 function. Okay, phi of n, it can be written as n into 1 minus 1 upon p1, 1 minus 1 upon p2 and so on. So if you wanted to know how to find the values by using Euler-5 function, you can check it into my previous videos. I explained there in detail with the example how to find Euler-5 functions. Okay, I use here Euler-5 function. So 5, 7 is a 6. So total number of element of order 1 and total number of element of order 7, which is a 6 plus 1, it is a 7. Okay, so I got the total number of element of order 1 and 7 is a total 7, as we did in our previous lecture of a group of order P into Q. Similarly, I did it here. Now let's move further. Then we want the leftover element, which is of order 7. Okay, so sorry, of order 3. So I got the element of order 1, element of order 7, and remaining we want the element of order 3. Then total number of element of order 3. Order 3, that means we have the element of order 1, 6, 1, 3 and 7. So I got the element of order 1 and element of order 7. So if we substitute the element of order 1 and element of order 7 from our group, then left over the element of order which remained for order 3. Okay, so total number of element of order 3 in G, that means order of G minus the total number of element of order 1 and 7. Okay, so total number of element of order 3 in G, so order of G is here 21, and total number of element of order 1 and 7, which is a 7. So 21 minus 7, it remain 14. So the leftover element here, which is the element of order 3. Okay, so total number of element of order 3 in a G is a 14. So I got the element of order 1, element of order 7 and element of order 3. And if we know the element of some certain element of order of some certain element of group, then it is easier to find out their subgroup. Okay, and we know that the subgroup, for finding subgroup of any elements, we use the result number of element of order D in G, which is a number of element cyclic subgroup, or number of subgroup of order D in G, which is a number of element of order D in a G divided by phi of D. So that result we are going to use it here. Okay, so you can see here I want the subgroup of order 3 in a G, which given in example. Okay, subgroup of order 3 in G, that means number of element of order 3 in a G. Okay, so how many element of order 3 in a G? I found it here 14, and divided by phi of 3. It is a Euler-5 function. Okay, so phi of 3. So we have to find out the value for phi of 3 by using Euler-5 function, which is a 2. It is a prime number. Always remember one trick here. If Euler-5 function for prime element, okay, so if you wanted to find Euler-5 function for prime element, we have to subtract 1 from our that element. Okay, so 3 is a prime, then subtract 1, it is a 3 minus 1 is a 2, 14 remains 7, then it is a 7. Okay, so here I got the value for number of subgroup of order 3 in a G, which is a 7. So see how that answer is easy. Just we have to think little bit logically, because in our example we have given only order of a G and group non-abelian. So that information need to think on which way we can get the order of 3. Okay, because it is quite easy, and in our example just we want the subgroup of order 3. Okay, so I hope so you all have understood my today's lecture. So if you want similar lecture like my today's lecture, you can check it into my playlist. If you have doubt, comment me in a comment section. I hope so you all have understood my today's lecture. Thank you everyone. Thank you for my today's lecture.